All right, let's talk about some things that we maybe learned in Algebra 1 or Algebra 2 back in the day. We'll talk about end behavior here. So this is polynomial end behavior. Okay, so if we have some polynomial, and this could be like a quadratic where you have an x squared as your leading or as your highest exponent, or you could have an x cubed, which is a cubic, or a quartic, which is x to the fourth, or a quintic, x to the fifth, etc., etc. Right? It really doesn't matter what size it is or how many terms you have, and so that's why I have the plus dot 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 here. What really matters is just that leading term, the term with the highest exponent. Okay, and the highest exponent, whatever that highest exponent is, that's called your degree, the degree of your polynomial, right? And then the number that's in front of your the variable with the highest exponent is called your leading coefficient, right? So it's called your leading coefficient. All right, so those are terms that we'll use here. So if we have, and really those two things, the degree and the leading coefficient, tell you everything you need to know about end behavior in a polynomial. Okay, so first of all, if you have an even degree, so if, in other words, if n is even, okay, if your highest exponent is even, then it's going to be going in the same direction on either end. It's either going to be going up and up if your leading coefficient is positive, right? Like if a is greater than 1, if this number is greater than 1, then it's going to go up on both sides, right? It's going to go up on the left and up on the right as you approach infinity or negative, as you approach negative infinity or infinity respectively, right? So it'll approach a positive infinity on either side, in other words, okay? If a is negative, if a is less than 1, and I messed this up here. This should be 0, right? Sorry about that. So I said negative and positive, but yeah, this should be 0, right? So if a is greater than 0, if it's positive, you're going to have something facing up. If a is less than 0, then it will be facing down on both sides, right? Or at least it will be the end behavior as it goes left or right will go down forever on both sides, okay? So that's what happens if you have an even degree, or if n is even, okay? If it's an odd degree, if n is odd, then the sides alternate, okay? If you have a positive leading coefficient, it's going to go up on the right and down on the left, okay? And if you have a negative leading coefficient, if a is less than 0, it's going to go down on the right and up on the left, okay? All right. Now, it could do a lot of things in between, right? Like this even degree polynomial could do like something like this, right? Or you could have the odd one just be maybe just a parabola and that's it, right? Like negative 5x squared something 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 would be something similar to that, right? And then on this other side, you could have something that does has a bunch of turns like that, and or you could have something that's a little more simple, maybe that's just like that, and the same thing going down. So there's a lot of things that could happen in between the end behavior, but the end behavior remains the same, depending on those two things, whether even or odd degree, so that's the exponent, and then whether the leading coefficient is positive or negative, which is the number that's in front of that leading or that highest degree variable, okay? All right, so all that to say, so you can kind of visually conceptualize these. Like, first of all, so one thing I could do is I could just look at these and say, okay, this is an invisible one here. So this is a monomial, but still follows the same thing. We know this is actually a linear function. So since we have a 1 there, that means it's going to go up on one side, down on the other, right? Since it's odd. And since this is positive, a positive leading coefficient, it's going to go up on the right, down on the left, right? So as we approach negative infinity, as we go left, that means it's going to be going down forever. And so that means that our answer here is going to be negative infinity. All right. Okay. Now, another way to do this is to conceptualize in terms of computations. If you think of, okay, I'm going to start plugging in numbers that are getting more and more negative, right, or are getting larger in the negative direction, then I can think of, okay, what if I plug in negative 10? 20 times negative 10 is negative 200. What about negative 100? 20 times negative 100 is going to be negative 2,000, and and so forth and so on. So we'll get to negative 20,000, negative 200,000, negative 2 million, etc., etc., right? And we're just going left and left forever, which means that, or excuse me, down and down forever, I should say, because we're talking about outputs. And so our outputs will approach negative infinity as our inputs get closer and closer to negative infinity. Okay. All right, so you can do it either way. So you can think about it in like as in plugging in numbers, and think of like maybe a kind of a table, and you can either write it out or you can do it, just in your head. Or you can think of it visually, like we talked about with that end behavior. Okay, so either way it works with me, and you don't have to show any work on these particular questions. You can just go, straight to the answer. Okay, so here's another one. This is another one where we have x to the first power, so it's odd. And we know this is a linear function, right? So we know lines go up in one direction, down in the other, right? They're diagonal. And so if we have something in y equals mx plus b form, it's going to be a diagonal line, right? And so here we have a negative slope, right? Or a negative leading coefficient, so we know it's going to go down, down on the right, and up on the left. Okay, so in here we're going left. So it's up on the left, and so that means we're going to approach positive infinity, okay, because it's up on the left. So once again, that's the visual or the graphical kind of interpretation. Or we can think about, okay, what if I just start plugging in numbers that are that get more and more negative in for x? So if I plug in like negative 10, negative 6 times negative 10 is positive 60. 60 plus 7 is positive 67. If I plug in negative 100, I get positive 607. If I plug in negative 1,000, I get positive 6,007, and so forth and so on, right? So we're just going to keep getting bigger and bigger, and that 7 is going to become more and more inconsequential as I add it to larger and larger positive numbers, because I'm multiplying a negative in here by a negative out here, and so a negative times a negative equals a positive. And so we approach positive infinity, okay? So really you don't even have to worry about these other numbers, because once again, those are going to become inconsequential as you get closer and closer to these larger numbers, whether they're positive or negative larger numbers. These will become inconsequential, okay? All right. Okay, so let's look at this one. So here we have one where we have even. So we know we're going to go the same direction. We're going to go either up and up or down and down. And since this is negative, that means we're going to go down and down, right? And so so no matter which side we approach from, even though this is from the left, no matter which side we approach from, we're going to go down forever. So it's going to be negative infinity. All right? Or, once again, the other way to do it is ignore this number, right? And just think about, okay, as we approach negative infinity, that means we're going to be plugging in numbers that are negative, that are more and more negative, right? But if you raise a negative number to the fourth power, it's going to turn positive. So you'll end up having these positive numbers that get bigger and bigger in the positive direction after you've raised them to the fourth power, but then you're going to multiply those really large positive numbers by negative 6. So negative 6 times increasingly positive numbers is going to be increasingly, or you can think of it decreasingly negative, right? It's going to be the numbers are going to be decreasing, so they're going to get larger in the negative direction. Okay, so it's going to go, it's going to be that one, down forever, or negative infinity. All right, and then finally, example 4 here. So here we're plugging in positive infinity, right? So once again, we can ignore this negative, or this plus 7 here, and so positive infinity, as we plug in numbers that are larger and larger in the positive direction, and we raise them to the 7th power, they'll still stay positive, right? But then this negative is going to turn them all negative, and so we'll have this will actually approach negative infinity. Okay, so because generally if we didn't have this sign here, this sign, if it was gone, this would go to positive infinity, but that negative flips it to, flips all those positive numbers to negative numbers. Okay, or we can think of this, since this is odd, that means we're going up in one direction, down in the other. Since this is negative, that means we start, or on the right it's going down, and on the left it's going up. And so since we're going to the right to positive infinity, that means we're going down forever. So it'd be negative infinity. Okay. All right. So those are polynomials, and that's how you can do those. You can either think of them graphically using what we talked about here, and you know, feel free to put these in your notes and use these on the quizzes and tests, or you can just kind of think about, you know, kind of like a table. If you plugged them in, you know, what would happen if you plugged in numbers that were bigger and bigger in the positive direction, or bigger and bigger in the negative direction, right? Or you can even just graph these specific functions, right, and check it out that way. So a few different ways you can do these, but yeah, and you know, pick which makes most sense to you.